Hi friends, welcome back to this series on data structures decoded. So we have been looking at what we call a linear data structure, and under linear data structure we have looked at two types of linear data structures. One is array and the other one is a linked list. Under linked list we have seen basically three types of linked list. One singly linked list, other is doubly linked list, and the third one is the making the linked list instead of a linear, just make it a circular. So we have a circular linked list connecting the last node back to the first node. So we have a circular linked list with single links or double links. Both are possible. So if it is single link, then we can just keep traversing around the loop in one direction. But if it is a doubly linked circular linked list, then we can traverse either clockwise or anti-clockwise. Both are equally possible. Now it is time to see what are the advantages, what are the applications of these linear data structures, and one of the most commonly used application for any linear data structure is what we call a stack. So stack, the word has derived from a stack of plates. I can see from this image. So what actually happens is we are working with a plates which are maybe made of glass, so delicate to use them. So if we want to add a new plate to this, definitely it is common that we try to put it on top of this. So the new plate we just add on top of this instead of inserting somewhere in between or at the bottom. We just try to put it on the top. And if we want to take out one plate from this, definitely nobody cares or dares to pull out any other plate except what is there on the top. So that means there is only one point of operation. If you want to add, it comes on the top. If you want to remove, it is from the top. So there is only one point of operation. So when we are looking at the adding the plates, the first plate added will be at the bottom, the last plate added will be on the top. And when we are removing it, the first plate removed will be from the top. Therefore, the top was the one which was added last, and that is coming out first. So this type of thing we call a last in, first out type of action. So stack is a fundamental data structure that follows the last in, first out principle. So the abstract data type that restricts access to only the most recently added element, which we call the top of the stack. So the data which we can access is only one possibility, which is the most recently added one. That means the one which has gone in last, only that will come out first. So the common operations, in case of stack of plates, we say keep the plate on top of the stack or take out the plate from the top of the stack. But in our data structure language, we have a name. Keeping a plate, we just call it push. So push a new element into the stack. That means it goes on top of the stack, and then pop is the other operation which is removing from the stack. So it's coming from the top of the stack, and one more operation we have is to peep in, just to look what is there on the top. So the difference between pop and peep is pop takes out one plate, whereas peep just tells what is there on the top. So pop removes one data element, whereas peak tells what is there on the top. So commonly used in expression evaluation, maybe if you want to check the syntax and trying to see whether the parentheses used are in right order or not, then for every parenthesis we push it onto the stack, and then uh, opposite, that is for every opening parenthesis we make a push action, and for every closing action we try to pop. So if we have a square bracket opening, then it gets into the stack, and the first thing we should get, if the order is right, then the first thing we should get is a closing square bracket. That means whatever the sequence of brackets are there in the expression, then in the expression, whatever was the last opening type of bracket, the same closing type of bracket should be in the beginning, the closing side. So we try to match. That means whatever was the last here should be the first here. So last opening, first closing should match. So in that case, we make use of stack more efficiently. Like we'll be using memory management. So when we are calling a function, then we should know which one had called it. So if one function, say one function A calls B, then B calls C, then C calls D, then after D done its work, it should come back to C. After C is done its work, then it should come back to B. Then after B, it should come back to A. So while calling it is A, B, C, D, but while coming back it should be D, C, B, A. That means it should be in the reverse order. So whatever has come first should come last, or whatever has come last should come first. So in the memory management, when we are trying to call the functions, definitely we would like to use stacks. And same way, in case of undo redo functionalities in the softwares, we efficiently make use of the stack. So as a example, we can see that we begin our stack with four elements: 10, 20, 30, and 40. So four elements are there, and 40 was the last element added into the stack. Therefore, top is showing now 40. And if we add another new one, so to add a new one, we use the function called push. So if I say push 50, then 50 goes above 40, and now onwards this position will be referred to as top, because this is the latest entry in the stack. So next time when we try to peek it, then it will just say that on the top of the stack we have an element which has a value equal to 50. But if we pop it, then 50 comes out, and the top moves down. Whereas in case of peak, it's only output will be 50, but the value of top will not change because we have not removed this element. But with pop, we are removing this element. In case of push, we have to tell that we have to push 50, but if in case of pop, we don't have to say anything, we just say pop. So here it is saying pop 50, but not required. We have to say just pop because we don't know what is there on the top of the stack. So we just say pop, then 50 comes out. If we say peak, 50 comes out. The difference between these two is here top does not change its position, whereas here top comes one step behind. So these are the two uh, functions we are talking about. So just whenever we want to push an element, read the element, then increment the top, then at that position add the new element, and if you want to pop it, then the print whatever is to be popped and the top value reduced by 1, so that next time this current position will not be used again. So this is how we can implement using arrays, and this is how we can implement using a stack operations using the linked list. So this is a push. So we create a new node, and then the new nodes next will be the top. So this was the top, and if we add a new node, then new nodes next will be the top, and now onwards this new node will be called top. So we create a new node, add data to that, and then new nodes next will be top, and top is now onwards will be the new node itself. So new node itself will become top from now onwards. So that's the push operation. And if you want to look at the pop operation, then we just note down what element was being popped, and then we move one step down. So tops next will become top now, and then free the element, free the node temp, and then return the value which was popped. So that's the stack operations we can perform using the linked list. So that's all about the stack. We have one more important activity which we call queue, and that's our issue of discussion for the next session. So keep watching. Thank you.